Okay, so before I get to the binomial setting for this next calculator demo, I forgot in the last video I left some folks hanging, but we did stat calculate one variable stats, right? We had L1 and L2, but a lot of people don't have this as their menu setup. When they press one variable stats, they don't get that, okay? What they get is just this. It's gonna say one variable stats on your screen, and after one variable stats, you're going to need to hit second and the number 1 for L1, a comma, and second and the number 2. This will have the same effect. So if you have an older calculator that doesn't give you that menu setup, when one variable stats comes on your screen, hit second and the number 1 for L1, press the comma, and then second and the number 2 for L2, so your screen looks like that. Then when you execute that command, you'll get the same as the rest of us. So I apologize if that left anybody hanging. You couldn't get through that step. But I want to start off with that for this video. Now, what we're doing with the calculator here is a little bit different. It's a very, very specific type of discrete random variable. It's a binomial random variable, and we use the acronym BINS to remember that something is binomial. It should be binary. In other words, there's one of two possible outcomes each time. The trials should be independent. That's the I in BINS. The N stands for number of trials is fixed. And the S stands for same probability on each trial, which is kind of similar to independence, but not exactly the same. But so here it says 39% adults favor the use of unmanned drones by police agencies. So that's our probability that's not going to change. Every time we go to any random adult, we're going to assume that the 0.39 probability that they favor the use of unmanned drones is in play and is true. Here's our fixed number of trials. 12 U.S. adults are randomly selected. So we're going to go to each one of these 12 adults, and each time we're going to do it, we're going to ask if they're in favor of unmanned drones. So the binomial setting says, what's the probability, we can do all of these, that exactly 3 out of the 12, that'll be a very basic binomial setting, at least 4 and then less than 8. That's where it's going to get a little bit tricky with our calculator. So I'll try to reiterate what we talked about in class in terms of how these work on the calculator. So for the first one, exactly 3, that's the easiest setting here. So this is under, usually we're in the stat world, but this is under second and the variables key. What you're going to see there in blue is distributions, right? So for the next couple weeks, we'll be using this a little bit when we have a binomial distribution and when we have a normal distribution. So anytime that you have a specific distribution that a variable follows, you want to find that distribution key. So it's second and the variables key, okay? And we have normal, PDF, CDF, and all these things. You can either arrow down or arrow up, but what you need to go and find is, these are the two that we're going to use in this example. We have binomial PDF, which is the first one we're going to use, and then the binomial CDF is for those second two examples that are a little trickier, right, when we want a whole bunch of numbers, right? So in that second one, at least 4. So at least 4 means 4 or 5 or 6 or 7. That's where we'd be adding a lot of stuff up. Less than 8 means anything less than 8. So adding up the probabilities of 0 successes all the way through 7 successes, okay? So those are cumulative binomial settings. That's what the C is for. So when you see CDF, think the C stands for cumulative, and PDF is just one specific instance. So I'm going to press enter, and I get my binomial PDF setting. Again, if your screen doesn't look like this, don't panic. I'll show you how this is going to work. It's basically, you're going to type the exact same things, but you're going to separate with commas. Okay? So what did we have in this example? We had 12 trials. We're going to 12 different adults. Each time we go to an adult, we have the same probability, 39% or 0.39, that anybody is going to favor the use of the unmanned drones. And then the first question was, what's the probability exactly 3 people out of those 12 are going to favor the use of the unmanned drones? Okay? So when I press enter, I get my probability. So everybody else, your screen's just going to look, this is going to say binomial PDF. You're going to type in 12, the number of trials, comma, P, the probability of success on each trial, comma, and then X, the number of successes that you want to measure, the probability of. So now when I press enter, I get 0.1526. So I'll go back to my stat lab, round to 3 decimal places. So that would be 0.153, right? To 3 decimal places. Right, 0.1526 to 3 decimal places, 0.153. We got nice work. Now this one's a little trickier. greater than or equal to 4. So if you're in class, you remember that I explained to you, we're going to use the binomial CDF. So it's second and the variables key again. Okay? You can't use second enter there because you have to get the CDF command. So I need binomial CDF. Now, this is going to be similar. We wanted more than 4, or more than or equal to 4. So basically more than 3, if you think about it. The calculator does not do this directly. What your CDF does is it will add up 0 through X trials or successes of those trials. So I want 4, 5, 6, 7, 8, 9, right? So what I'm going to do is use the calculator to add up 0 through 3 successes. When I get 0 through 3 successes, I can subtract that from 1 to get the probability that I need. We use our probability rules from last week. So I still have 12 trials. My probability of success is 0.39. And then the X value here, this is where it's tricky, is 3, right? Why? Because this is how your calculator works. It'll only add up 0 through X success trials. So if I add up 0 through 3, then this answer that I get, I'm going to have to subtract from 1. You just have to keep that in mind. So I press enter, and I get 0.247. So what I really want to do here is 1 minus 0.247. Okay, so to 3 decimal places, that would be 0.753. Go back to my math lab and see if that's right. Good. So remember, we have to, if it's greater than or equal to 4, add up 0 through 3, that's everything you don't want, and subtract from 1. This one, we won't have to subtract from 1, because what does it want? It wants less than 8. So this one is really asking me to add up 0 through 7 successes, right? 0 through 7 successes would be less than 8, and our calculator will do that for us right away. And if I want, I can do second vars again, or we can use our little trick and do second enter, and second enter again. And now I don't have to go back on my Easter egg hunt to find binomial CDF. It's right here. I just second entered and brought it back up. So what do I want to do? I want less than 8, okay? Not equal to 8. This is going to add up less than or equal to 7. It's always going to include the number that you put in here. So remember what my stat lab is asking me for in this example is less than 8. So I'm going to add all the way up to 7, and that's going to be exactly what I want. I don't want to include 8 in that. So I press enter, and I get 0.95. To 3 decimal places, 0.951, right? They want 3 decimal places. So 0.951, okay? And we can move on to the next question.